Welcome to the section on abutment sliding. So first, I want to point out the subtle difference in wording here. The previous section was about anchor uplift. So we focused on the anchor. And to draw our free body diagram, and the weight resisting uplift is that overburden here. So I have this on the left. This section will focus on the abutment as a whole, because we analyze the entire abutment as a block sliding on a hill. Force flows from the cables into the anchor, which pushes and dissipates the force into the abutment as a whole. So the component design checks, which were a previous section, are how we confirm that all of this is actually happening within the abutment. When we check the ramp walls as compression struts and the anchor as a reinforced concrete beam that are sufficiently strong enough to withstand these internal stresses. But in this case, and moving forward, we're going to view the this entire portion as one block in sliding, and we'll call that the abutment. And I've drawn a free body diagram here, not inclusive, but just to show an example of some of the forces that are going to be on that block that is sliding. So moving forward, the learning objectives for this module are going to be first, to understand all additional checks for abutment sliding and the various ways in which we can add sliding capacity. 2, evaluate methods for realizing more sliding capacity using engineering judgment. And 3, analyze the various slope and abutment placement conditions for their effect on sliding capacity. So we will revisit the basic course for a moment, which shows sliding, or a driving force RS, is equal to P active plus pH in red, where P active is the active earth pressure and pH is the cable force on the anchor beam. pH is described in detail in the cable analysis section, and I won't repeat that here. But this view just looks at the sliding of the anchor beam, kind of like uplift, how we just looked at the uplift of the anchor beam and its overburden area. But when we are viewing the entire abutment block, we need to take a step back and include this term pH tower, as you may remember from before from the cable analysis section. pH tower comes from the friction over the saddle. So we can't ignore this because this friction is still acting on the entire abutment as a block. So as you remember from cable analysis, this is the term for pH tower, which kind of breaks down to the horizontal forces in the mainstay and minus the horizontal forces in the backstay. This gives us our final free body diagram onto the abutment. And I haven't drawn out pH tower in this because it is, like I just mentioned in this equation above, the resultant of the mainspan and backspan forces at the tower. So adding that pH tower would essentially be double counting here. And in the next section, we're going to talk about additional ramp weight in terms of abutment sliding.